Hello, MUS 1002 students. Today, we are going to go over three of my favorite acronyms in music technology: DAWs, MIDI, and VSTs. So, let's start off with the DAW, the Digital Audio Workstation, and why it is effectively, at least in terms of digital audio, the greatest thing since sliced bread. So, digital audio workstations, that is the common thing that is referred to as a DAW. In order to be a digital audio workstation, it is a piece of software that must have three common characteristics. First is the ability to record and edit audio freely and non-destructively. Second is the ability to record, sequence, route, and edit MIDI data, including synthesizing it to audio. We'll talk about MIDI in just a second. Third is the ability to mix audio and MIDI using standard tools for things like panning, volume, and EQ. And they should also have the ability to have automation for pretty much any parameter, so that the user can record and define curves for a parameter to make it automatically do things like move the volume fader up or down, move the panning knob left or right, adjust, say, the dry-wet balance on reverb, or even sweep a filter in the EQ. Most DAWs can commonly record, import, and edit multi-track audio, which is anything more than one channel. By default, this is usually stereo, but most DAWs can handle surround sound, which would be quadraphonic, 5.1, 7.1, or octaphonic. And some can handle ambisonics, which is a full 360-degree immersive audio format that uses 16 to 64 channels, or even the Dolby Atmos immersive audio format. MIDI stands for Musical Instrument Digital Interface. So it was proposed in 1981 and released in 1983 at the NAMM show with a demo of a sequential circuits Prophet synth connecting to a Roland Jupiter 6, allowing both synths by totally separate manufacturers to communicate and play at the same time. You could play the keyboard of one, it would play both. So MIDI is a standardized communications protocol for digital instruments that communicates some really very basic parameters, whether a note is on or if it's off. The velocity, how hard a key is struck. Dynamics, volume changes. Program changes, so you can change between sounds. Or control changes. These are any knobs or pedals or faders that might be on the keyboard, including things like the sustain pedal and the value that is associated with that pedal, if it's continuous or if it is a discrete controller. The big thing to keep in mind is that MIDI is not sound. It is just a set of instructions for a synth or a plugin on how to create and perform that sound. What notes are being played? Where does the note start and stop? What is the velocity of that note? With just that information, I can record a MIDI clip using just my standard piano-style keyboard with a default sine wave sound. I can then take that same clip and send it to a synthesizer plugin, and it will play back with whatever that synth plugin sounds like. So it's really cool. You can record one clip, you can send it to different things and get different sounds out of it. The data can be sequenced or programmed or arranged in a number of ways. The most standard way is to use the piano roll in a DAW, which is so called because it looks like a player piano roll. You have a piano strip of white and black keys on the left that forms a grid. Other ways can be using standard musical notation in a notation editor like Dorico, Finale, MuseScore, or Sibelius. Most DAWs have a drum grid, which is similar to a piano roll, but with fewer notes. It will only have a number of notes, lanes equal to however many drum samples are being used. Finally, there's an event list, which is generally only used to debug because you're looking at just a list of MIDI events as they happen. But it can be used manually in computer programming languages like Max MSP, Pure Data, Sonic Pi, or Super Collider as well to create a sequence of MIDI events. In terms of cables, MIDI typically uses either one of two things. Most common nowadays is USB, just like everything else. But you will also see a 5-pin DIN cable that is commonly used on older gear. Regardless of how it's connected, a MIDI cable can carry and route 16 channels of data, each of which can be used to control a separate instrument plugin or hardware device when properly routed. Nowadays, you also have Bluetooth MIDI devices, fairly common, that are very, very popular to use with, say, an iPhone. But in any case, for every type of MIDI, Channel 10 is special. Channel 10, per the MIDI spec, is reserved for drums and percussion. Yes, you can use it for other things. That is possible, but by default, that is reserved for drums and percussion. And that is where if you have a drum plugin, it's going to expect your MIDI data to come from Channel 10. In terms of controllers, there are a bunch of different options. The piano keyboard layout is the most common and the most easily found and purchased or obtained for free on Facebook Marketplace or Craigslist. But there are some others that are really cool, like the electronic wind controller, or EWI, which uses a fingering system similar to wind instruments, and you can usually choose between a couple of different fingering systems. You have drum controllers like Roland's V-drums that are a drum set, but just with plastic and rubber-coated pads that you hit. Then you have grid controllers like the Keith McMillan Instruments Cuneo, Ableton's Push and Push 2, or the Linstrument that use a MPC-style layout, or in the case of the Linstrument, a very, very large number of cells in the grid. Here's just a little example of what sequenced MIDI information looks like. This is taken from the Dorico notation editor, and you can see that in the blue section down here, I have a piano roll. It's got the piano notes shown, and it's showing where the notes are with these little boxes that are drawn in. I have dynamics information here, which is shown. That's just as a automation curve, and I have velocity information for each note as well. I also have playing techniques, which is a bit specific to that specific program. In other MIDI editors, that would be program changes. So a little history. MIDI and DAWs are pretty much inextricably linked at this point. In fact, MIDI came out first, and it was incredibly popular pretty much as soon as it came out. The fact that it was built into Yamaha's DX7, which is one of the most popular synthesizers of all time and a staple of pretty much every pop genre from the 80s to the early 2000s, definitely helped. In fact, a lot of people started wanting ways to get MIDI onto a computer. So Roland was one of the first corporations to offer a computer MIDI add-on in 1984. Then in 1985, Atari, who was in the business of making computers and not just failed video game systems, built MIDI into their ST and Falcon computer lines. And in fact, the very first-person shooter game is called MIDI Maze, and it was for the Atari and used MIDI instead of networking over LAN to communicate between multiple computers so that you and your friends could set up a MIDI network and kill each other all night long and have fun with that. Hey, everyone's got to start somewhere. In 1984, Apple's Macintosh quickly became the platform of choice for audio work. This is because while it required an external MIDI card in order to function, Apple's kernel allows for a lot of really strong timing in terms of audio events, and it still does. It is the preferred platform for doing MIDI sequencing and for audio recording. In 1989, Steinberg released Cubase for the Atari as a MIDI sequencer. Cubase would later become a DAW, and that is an important first step. Also in 1989, Sonic Solution released Sonic System, which was the first professional non-linear audio editor and CD mastering program. You could take digital audio, you could edit any part of it at any time, and it wouldn't affect everything else further down the line. You could use it to master audio and then actually burn it to a CD as your gold master that you would use to create all of the other CDs for an artist. Stereo only, but again, you have to start somewhere. Also in 1989, DigiDesign released Sound Tools, and that used the expansion bus of the Macintosh 2 to add a 2-channel audio converter, both analog to digital and digital to analog, which allowed for digital signal processing for time stretching and pitch preservation of stereo audio. This is the revolution right here. This is where everything really starts going over to computers. In 1991, Cubase gained the ability to edit audio, only for the Mac though. Also in 91, Sound Tools became Pro Tools, which is still to this day one of the industry standard pieces of software for DAWs. And they expanded it so that you could edit and record 4 channels of audio at once. Cubase, never one to be left behind, was ported to the PC in 1993. But only as a MIDI sequencer. PCs have always had a slight problem with how they handle audio due to how Windows works with audio drivers and the Windows kernel itself. It's gotten better, but it is still not the preferred platform for a reason. But working on this, Cubase did add audio recording to the PC in 96. And then in 97, Pro Tools was ported to the PC for the first time. They have been both Mac and PC ever since then, up to the present day. There is a problem, though, and that is that studios had tons of expensive hardware modules for processing audio, like EQ, compressors, filters, limiters, etc. And in order to use those, you would have to send audio out from your DAW through the effects chain, through whatever effects you wanted to use, and then record that onto another track in your DAW. So that was a large pain. It took time. If you made a mistake, you'd have to go back and re-edit it. There was a lot of impetus to create plugins for DAWs that could replicate a lot of the studio gear. And in fact, pretty much every DAW manufacturer created plugins. But the problem is that early DAWs all had different formats. So if you owned multiple DAWs, which was very common and still is very common in a professional studio, you had to buy the same plugin again for every single DAW. So if I owned Pro Tools, I would have one format. If I owned Cubase, I would have another format. If I owned a third piece of software, I would have a third plugin format. And if I wanted just the same EQ, I would have to buy it 3 times. At $100 a pop, that adds up very quickly. So to help with this, Steinberg introduced VSTs, or Virtual Studio Technology. This is a specification and a set of development tools that they released in 1996 to try and standardize plugin formats. Using the dev tools, you can create a graphical representation of hardware devices with all of the standard knobs, faders, other parameters, and even get pretty good pictures of the device itself that are expected by the user on their hardware devices, but you can just put them into a window on the computer. Then, in the background, your code is handling all of the signal processing. and doing the same effects, but again, on the computer. And more importantly, it's doing it in real time. So you're hearing the effects. You're hearing what happens if you turn a knob on your VST, and it's happening immediately. Because they're on the computer, they can also be automated. So you can create a curve that will automatically change the balance and bring up more reverb in the mix, which makes them much more powerful than the hardware versions in some cases, because with the hardware, you would have to have someone sitting there standing and turning the knob manually, which can usually work, but anytime they mess up, you have to re-record. Then the best part is that in 1999, Steinberg expanded VSTs to VST instruments, or VSTi. These acted as plugins that would take in MIDI information, process that MIDI information through whatever synthesis or sampling program they had loaded as an instrument, and output the audio. So suddenly all of this outboard gear that you had, MIDI modules that were just designed to act as a synthesizer that would take in MIDI and output audio, that was on your computer. You no longer needed to have gigantic rack spaces. And for the first time, you could start working entirely in the box, just on a laptop. The result was that VSTs became extremely popular and were adopted by many companies for their DAWs as the plug-in standard. There are two exceptions for this: Pro Tools, which previously used the RTAS format and now uses AAX, and Logic, which only uses the audio unit, or AU, plugin format. It was also generally helped by the fact that a lot of plugin creators figured out that by offering a couple of free VSTs to show off what their product line was like, they could hook new customers really easily. Give them a freebie or two, then they come back and buy your parametric EQ. So this also led to another problem, which is piracy. With the rise of the internet, VSTs were shared on file sharing sites like any other file. In fact, because of this led to a resurgence of different copy protection techniques that DAW manufacturers and VST manufacturers tried to use to combat piracy. There were things like the use of a noise burst every 30 seconds in the case of FL Studio. Most manufacturers, however, adopted the use of hardware, like iLok dongles. That is what this is. It is just a USB key that I plug in directly into my computer, and if that's in there, I can use my VSTs. With others, I have to use what's called an always-on connection, where they are constantly communicating with a licensed server, and if that connection ever goes down, then I can't use it. That is kind of the favored method of Pro Tools, and not my preferred method, because things happen. Another way that they tried to combat piracy was with challenge questions, where every time you loaded a VST, it would ask a question like, what is the 7th word on this page in the manual? Or they would email answers to a legitimate user's email as a sort of early two-factor authentication method. All in all, these measures can be annoying, but most users, especially in professional studios, are very happy to support manufacturers of quality products. There's a reason why I own multiple iLoks, because I am happy to support those VST creators, and I do like to have a backup in case I leave one in my office at the university and need to work on something at home.